Hello and good day everyone, my name is Ron and let us answer some neural networking problems. Take a look at the data here, which is in this Excel, and use the neural networking fitting app in MATLAB to determine if the variables have a correlation or not. So for those student numbers ending in an even number, set A, determine the correlation between temperature and dissolved oxygen input variables with the total biocount as the target or output variable. No need to make the concentration units homogeneous. So since, as you can see here, my student number is an even number, so I'm in set A. So all those in green are my set, and also those that are not in color. So all those in blue I will just ignore because they are specifically for set B, because I'm only for set A. Continuing, that my input variables in this question are temperature and dissolved oxygen, and I would like to know if these two have a correlation to the total biocount, which is the output. So for both set A and B, use the data from August 1, 2017 until August 31, 2018 and take note that you have missing values on your data set. So for set A, fill up all the missing values except for temperature with the average values, and for temperature, you can use the previous temperature readings to fill up the missing values and use the Liebenberg-Marquardt training algorithm. Use the default setting for the partition of the training, testing, and validation data set. So what do I need to determine? I need to determine the R values and the mean squared error. And what do the R values tells us, and I will also try to increase the number of neurons twice or thrice the original number. And what do I observe with the resulting R and MSE values? So with that in mind, let us go open our MATLAB, and we need to prepare our data set. So going back to the Excel, this is the original Excel. So when you download this Excel, you'll only be given these two sheets. So according to the problem, our data ranges from August 1, 2017 to August 31, 2018. And now to ease in our predicament, I would scroll down here and go to August 2017, August 1. So here, August 1, so this is the end. This is the start, August 1, 2017. So this is my starting data set. And I would range it until August 31, 2018, which is this one. Okay, then what are my input variables? My input variables are temperature and dissolved oxygen. So as you can see here, my temperature is all highlighted here and dissolved oxygen is highlighted here. And as we analyze the data given, I have no zero data, or have no blank data as I examined it one by one. So as you can see here, there's no zero data that I can observe from August 31, 2018. And I put that here. And then for my output, which is the total biocount, I will need to go to the August 1, 2017 area, which is around here. So this is a highlight. So this is the starting highlight, total biocount. And as I go down to August 31, 2018, as you can see, there are some data sets missing, such as this one and such as this one as well. So what I did is, according to the problem, for missing values, I would need to find the average values. So since this is not temperature value anyway, this is a total biocount value, I would need to use the average values. So how do we find the average values? Well, I click this. In Excel, we can just press equal sign, then write here the average tool, then find the average of the top two parts. Then, so that is how I got the average of those blank values. Then I keep continuing it until I filled up all, and until I reach the end of the data set. So this is this one originally. I already done it in advance, so there's no need to do it one by one again. So after doing it in advance, so this is all the data sets. So this ranges from temperature, even total phosphate, dissolved phosphate, and oxygen, and total biocount. But I only need temperature and dissolved oxygen, so I made another set that only constitutes the inputs, the two input values, which are these two, and the output, which is the total biocount. So since our data set is prepared, how do we input this in MATLAB? So first things first, you need to go to your workspace, click on new, and we need to make an array. So we need to put here, so we click here new and input, then double click, and you'll give a also similar Excel graphical interface. So I will need to put here in my first column my first input variable, which is the temperature data. So as I copy paste, here we go. So this is the temperature data set. And then as I scroll up, I will also need to include the second input variable, which is the total, the dissolved oxygen, sorry. Then afterwards, I would need to highlight them both, and I need them to be transposed to be a 2x396 array. After that, since our input array is defined, we need to define our output array. So our output array, we need to click on New again, and click here Output, and double click in order to go to the Excel interface. Afterwards, this one, still the same, highlight. And again, before you highlight everything, make sure that there are no blank data. You need to make all the blank data, which is the zero data, you need to find the average value as I said earlier. So I already did it earlier, so that we would continue with the explanation. So again, highlight everything, copy, and paste it here. And still the same, we need to transpose the data, transpose variable, so here. And now our input and output are defined. And now what's next is we need to go to the apps, and we need to click on neural net fitting. So if you click on your apps on your own MATLAB and you do not find the neural net fitting, just stay calm and just go to install app and install the get more apps or install app, and you need to install the deep learning app pack. So after you download the deep learning app pack, you'll have the option to do neural net fitting. So you click this, and then these are the instructions. So you click next. And what are my inputs? My input is the already prepared input array. So this is the input, which is a 2x396. So this is also 2x396. So this is the file that we are referring to. And then for the output, it is a 1x396, also a 1x396. Then matrix columns, then click next. So this is the standardized optioning, which is the training, validation, and testing. So according to the problem here, we can just use the default settings, not really standard, sorry. Default settings, we don't need to change the default settings anymore. So we'll just click next. And the hidden neurons. So according to the problem, we will initially start with a hidden neuron number of 2. So we'll put here hidden neuron number of 2. In both cases, two hidden neurons. So we'll click next. Then the training algorithm to be used is the Liebenberg-Marquardt. And then we train. After training, we find the plot regression. So as you can see here, the R values are not equal to 1. They are very, very far from 1. So let's do it again. So remember, our first attempt is 0.31, 0.20, 0.19, and 0.26. So if we retrain again, it's different, 0.13, 0.34, 0.29, 0.16. So if I do it again once more, it has a different value as well. 0.27, 0.19, 0.26, 0.24. Why is that? Well, as you can see here, that the reason why there are different results as you keep on retraining it is because training multiple times will generate different results due to different initial conditionings and sampling. So when we train a neural fitting algorithm, it does different initial conditions every time. That's why it makes the results probabilistic in nature. Then we need to interpret our results. So for the training, it is very, very high, greater than 1. Greater than 1,000, if I may. The R is very, very less than 1, almost approaching 0. For validation and testing are also the same. So what does it mean? Well, the MSE, or the mean squared error, is the average square difference between outputs and targets. Lower values are better, 0 means no error, and the regression values measure the correlation between the outputs and targets, and an R value of 1 means a close relationship. So going back to the plot regression, what does this mean? This means that our input variables, which are temperature and dissolved oxygen, does not have an effect towards our expected output variable, which is the total bio count. So these variables are independent of each other. They don't have any correlation whatsoever, due to the fact that the machine, or the deep learning algorithm, this neural net fitting, proves or shows that they are not related. They're not correlated, sorry. So, but we also have another, so that's the R values and MSE values, and, sorry. So this is the R value and MSE value. Then according to here, what does the R value do? As I already explained earlier. So having a low R value means that the variables being compared, the input and the output, are not correlated whatsoever. They're independent of each other. Then try increasing the number of neurons twice and thrice the original number. What do you observe with the resulting R and MSE values? So let's do that. So we close these variables, we close these windows, and then we go back, and then twice the original number, so 2 times 2 equals 4, and click next, train. So I'll plot it again for simplicity's sake. It is still not reaching, what do you call this? It is still not reaching a it is not reaching a correlated value. So R is still close to 0, not even close to 1, and the MSE is greater than 1000 again. But as you can see here, it actually increases in R. So earlier our latest, when 2 hidden neurons, this R value is around like 0.16 something, and now here it's now 0.29. So it increased in R value. And if we go back again and thrice the original number, 2 times 3, which is 6, and click next, train, and nothing changed essentially, such that it's still far from 1. However, and the MSE is also greater than 1000 as well. However, as you can see here, the values are increasing. So as the hidden neurons get more and more larger, the R value gets closer and at least closer and closer to 1. So that's what I interpret as I keep on increasing the hidden neurons part of this algorithm. So though the problem only states that twice and thrice the number, what happens if we just change it to, I don't know, let's say 10, let's say 20, let's see what happens. 20 hidden neurons, train, and plot regression. So it actually lessens the R value again. So another instance on why does it happen, though I increase the hidden neurons, might be because there must be an optimal, I suspect that there must be an optimal hidden neuron value that can help us correlate it to 1. But since, again, this algorithm is probabilistic in nature, that we cannot actually have the same results every time we retrain the program, it is more on akin to self-interpretation. But overall, regardless on how many neurons that we did, the results showed that the dissolved oxygen content and the temperature of the water quality does not have an effect with regards to the total biocount of the water or the body of water in question. So that is my interpretation of the data. And again, my name is Dayap, and thank you all for listening. Have a nice day.